Let's go over overview of Rust. So for origin, it was created by Graydon Hoare at Mozilla Research around 2010. Graydon Hoare was a developer at Mozilla who needed a safer systems language. He began working on Rust as a personal project in around 2006. First prototypes implemented around 2008 to 2010, and officially announced Rust project in 2010. So he spent over 5 years in development, testing, and tool building. That's even though if it was announced in 2010, the first stable 1.0 release was in 2015. 1.0 release milestone indicated stability for real production use. The design goals, first is the speed, high performance comparable to almost C and C++, intended to be a systems language usable for tasks traditionally done in C, C++. It achieves high runtime performance through zero cost abstractions and also compiles to native code with low level control and manual memory management. Now, as per safety goes, its type system prevents memory errors like buffer overflows. It has a strong type system which tracks object lifetime ownership to prevent unsafe behavior. There's no null pointers, iterator bound checks, no data races. That's why it's more safe. For it also forces handling of errors instead of ignoring them. And then for concurrency, it's built-in support for parallelism and concurrency. It's very lightweight tasks and message passing built into the language. So that's why it's much better in concurrent programming. Its type system protects against race conditions, and then also it's easy to write concurrent programs that are safe and correct. For the reliability, it's rich error handling and minimal runtime crashes. Its errors must be handled instead of ignored. You also have results in fewer crashes in production, which this particular thing being reliable. So you don't have crashes or any other causes because you're handling the errors. Debugging is easier with well-typed program state. For the productivity, it's high-level abstractions. It uses the cargo package manager. Its expressive traits and generics encourage code reuse. Also, it has great documentation and tools. Cargo provides dependency management and build tools. For influences, emphasizes zero cost abstraction like C++. Its idiomatic Rust aims to have no runtime cost for abstraction use. Also, goal is to provide useful programming model with performance of manual C code. The memory safety without garbage collection like Swift and OCaml use are all patterns instead of GC for memory management. That's why it's memory safety. Uh, Compiler tracks lifetime and ownership statically, so it's much more safe. Functional influences from Haskell, ML, Scala. So the purity and isolation supported but is not enforced. There's also type inference, pattern matching, and enum variants. For the evolution of this, initially sponsored by Mozilla, significant external contributions, Mozilla pays core team, but much work is done by the community, allows for the default open development model. Also, rapid evolution and improvement of language tools, breaking changes routinely introduced to the language. There's also cargo toolchain rapidly being improved. Another strong focus on community building. It's inclusive, pragmatic philosophy kind of helps people to kind of get in and then work on making it better. Emphasis is on the education, documentation, and governance. So as per the philosophy goes, it's fast, safe, productive. You pick three. So setting Rust apart is the combination and balanced trade-offs. Also, other languages may excel at one or two, but rarely all three, and that's why it's fast, safe, and productive. Now, for balancing performance versus safety productivity, a zero-cost principle, but resists on premature optimization. There's also pragmatically uh, trades off between the bound checked arrays versus unsafe ones. For concurrency without fear, language features allow easy concurrent code and also stability and isolation between all the tasks. The applications, some of the applications include like system programming where you do OS, embedded, and drivers where you replace the C for performance critical task. NASA, Microsoft, Dropbox, Cloudflare they use Rust. Also for web services and network programming with high performance, high concurrency backends supported by frameworks like Actex and Rocket. Also has high performance computing for games, simulators, scientific. Often needs both performance and parallelism. That's why it's used there. These are some of the overview of Rust. We'll probably get into installation and writing your first applications soon.